us take a look at another example. So in this example, question says solve the following. Solve x dy dx minus 4y equals to x to the 6th e to the power x. So what is our very first step? Our very first step is to check the classification. Is it separable? Is it linear? So since so far we just talked about these two classifications, we're going to mention those. Step 1, what is the classification? Is it separable? Is it linear? If it's separable, then take the integrals of both sides. If it's linear, then you have to follow some steps. In step 2, apply the method that we just learned. Okay. So let's check to see which one is this. Is it separable? It's not separable differential equation. Okay. So let's check to see if it's linear or not. So remember the definition of first order linear ODE. Here you have a sub 1x, the first derivative, plus a sub 0x, y equals to a function like g. Let us check these two and compare them. Well, the expression, the coefficient multiplied by y prime is just x. Okay, so far so good. Here you have a sub 0x times y, the coefficient multiplied by y must be in x or the constant. So if you take a look at this -4, it means that you have plus -4. So far so good. And on the other side, you have a function in x, or it can be just a constant, and you get a homogeneous differential equation if it's 0. So your g is also good. So it means that you have a linear differential equation. Since it's linear, we have to follow the steps that we just learned. In the very first step, we need to write this in standard form. Standard form. How do you write this in standard form? You have to divide everything by x. So 1 divided by x. So if you divide it by x, what do you get? X divided by x, you end up with dy dx. And here you get plus -4 over xy equals to x to the 5th e to the power x. Okay, what is the second step? In the second step, we need to find the integrating factor. What is the integrating factor? Remember that if you have, for example, y prime plus px, y equals to qx, then the integrating factor is e to power px dx. Let's find this guy. So e to power, label this number, this 2, integrating factor. Here you have, well, e to power, what is px? Px is the coefficient of y. Your px is -4 divided by x. E to the integral -4 over x dx. Well, we already know integral. We already know what is the integral of -4 over x dx. This is equal to e to -4 ln of absolute value of x. But at the same time, note that when you write it this way, then both of these two functions, px and qx, both of them are continuous. Px and qx are continuous on 0 to infinity. On 0 to infinity, they have positive x values. So what's the meaning of that? It means that you can get rid of the absolute value. The integrating factor becomes e to negative 4 ln of x. Going back to algebra, this becomes e to ln of x to negative 4. You can cancel out e and ln, so your integrating factor becomes just x to negative 4 or 1 over x to the 4th. This is our integrating factor. This guy becomes just 1 over x to the 4th. Very well, so far so good. In step 3, we multiply both sides by the integrating factor. Integrating factor. Well, so we are on step 3. What do we have here? We have our standard form of the linear differential equation. So let's multiply that by integrating factor, which is 1 over x to the 4th. Very well. Okay, let's just copy down everything. Y prime. And here you have minus 4 divided by x times y equals to 1 over x to the 4th, x to the 5th, e to the x. Let us simplify the whole thing. So what are we going to get here? We're going to see we have 1 over x to the 4th, y prime minus 4 over x to the 5th, y equals to x e to the x. Very well. Okay, you can rewrite this way, which is, if it's easier for you to see that, you have x to negative 4, y prime minus 4, x to negative 5, y equals to x e to the x. Very good. So this becomes our differential equation. In step 4, on the left-hand side, you're going to see the expanded form of the product rule. So we're going to convert it back into the compact form, which is d over dx of y times the integrating factor. And on the right-hand side, you have some functions. Let's call it f of x. And then at the last step, take the integral of both sides. Very good. Nice work. So step 4, let me rewrite this here. You have x to negative 4, y prime minus 4, x to negative 5, y equals to x e to the x. Take a look at this. Remember that when you're talking about the product rule says, hey, if you have, for example, two functions like f and g, and you take the derivative, it is f prime g plus f g prime. What do you have here? You have the derivative of y times the function. Well, this function has the derivative. What is the derivative of x to the power negative 4? It is negative 4, x to power negative 5. Let me write it here for you. If you have x to negative 4 and you take the derivative, it becomes negative 4x to power negative 5. So this is actually the expanded form. If you just rewrite this in compact form of the product rule, you get y x to power negative 4. And on the right-hand side, you have x e to the x. Now just follow the last step. Step 5, taking the integral of both sides. Very good. The integral of dx of y x to negative 4 is equal to the integral of x e to the x. Very well. Based on the fundamental theorem of calculus, the integral and the derivative, they are opposite operations. They're going to cancel out each other. You get y x to power negative 4 equals to. But what is this integral here? Integral of x times e to the x. You have to apply integration by parts. So you have u equals to x, and here you have dv equals to e to the x dx. Very well. So du is dx and v is just e to the x. You get uv minus integral v du. So this becomes u times v, which is x e to the x minus the integral of v du. Very well. And we all know that the integral of e to the x is just e to the x. So what happens? It happens that we got to the solution, which is written this way. Here you have y x to -4 equals to x e to the x minus e to the x plus constant of integration. So next question is, can we just isolate y on one side? So this is y divided by x to 4. So if you just multiply this back by x to the 4th, you get y equals to x to the 5th minus x to the 4th. And here you have c times x to the 4th. So this is the family of solutions of the differential equation that we wrote in, that we have up there. This is the solution. Solution set, or the family of solutions.